Hello everyone, I'm Shamanth CSAT faculty at Insights. I welcome you to the CSAT series question of the day 26. In how many different ways can 6 players be arranged in a line such that 2 of them, Ajit and Mukherjee, are never together? See now, I'll give an example. 2 people are there. If I ask you to arrange them in a different ways or else make them in a sit in a different ways, they can sit like this, right? A, B. Or else they can sit this also. Different ways, isn't it or not? Okay. Or else 3 people are there, A, B, C. If I ask you to make them sit in a different order, okay, how many different ways? A, B, C, B, C, A, C, A, B, isn't it? Okay. B, A, C, C, B, A, A, C, B. Isn't it? Nothing repeated? Yeah. Okay. How many different ways? 6 ways. See, this is nothing but, can I write this as, if 2 people are there, 2 factorial. If 3 people are there, 3 factorial. 3 factorial is nothing but 6 only. 6 different ways. Now, if 6 people are there, if no condition is given, forget about this condition. Ajit and Mukherjee are never together. Forget about the condition. So, 6 people are there means how many different ways they can be seated? 6 factorial, that is equal to 720 different ways. Factorial is always ways. 720 ways we can make them sit by changing the order here and there. 720 ways. Now, Ajit and Mukherjee has to be always together. Okay, always together. Whenever they are always together, in whatever the position they go, see, Ajit and Mukherjee, whenever they go, wherever they go, they might be here, they might be here, they might be here, they will go with together only. Okay, look here now. Hence, Ajit and Mukherjee, A for Ajit, M for Mukherjee, put them together and tie them up and consider them as one person. One person. So, the remaining are 2, 3, 4, 5. Even though 6 people are there, I have made this into one person here. Now, only 5 people are there. If 6 people can be arranged in 6 factorial ways, 5 people can be arranged in 5 factorial ways. But this is not 5 people. You know that among themselves, okay, Ajit and Mukherjee can come here. They can come here. They can come here. They can come here. Okay. But whenever Ajit and Mukherjee are here, they need not to be in this order only, right? This can also be arranged as Mukherjee and Ajit. This becomes a different combination of sitting. Understood? Okay. See, AM, MA, isn't it or not? So, 2 people are there, hence 2 factorial ways. They can be seated together. This is, they can be seated together. Okay. See, this is nothing but 5 factorial is 120 into 2, that is 240 ways. In this 240 ways, always Ajit and Mukherjee will be together. In how many different ways you can make them sit? All of them can be seated in 720 ways, in which some of the ways Ajit and Mukherjee are together, in other ways Ajit and Mukherjee are never together. Out of these 720 ways, how many ways they are together? 240 ways they are together. So, they are never together for how many ways? Minus this ways, isn't it? In this 720 we have Ajit and Mukherjee are sitting together and not together also. Together we know 240 times. Not together how many times? 480 times. So, the answer is 480 here. This is the bouncer of yesterday's video. If average of 15 consecutive odd numbers is 29, find the sum of first and the last. See, look here now. These are the odd numbers 1, 3, 5, 7, 9. For example, consecutive odd numbers. Okay. Average, how to find the average? Average is nothing but sum of all the observations divided by total number of observations. Isn't it? If you sum this one, this becomes 25. Okay. How many observations are there? 1, 2, 3, 4, 5. So, 5. So, the average is 5 here. Isn't it? Okay. Do we have 5? Yes, we have 5. Similarly, okay, 3, 5, 7, 9, 11. The average is nothing but 7. Whenever you have consecutive such numbers, or else the difference between each successive number, if it is same, the difference between each successive numbers if it is same. For example, I will give you one more example, 5, 10, 15, 20, 25. See here also the difference between each successive number is same. These kind of numbers are called arithmetic progression, AP. Arithmetic progression. Whenever the series of numbers are in arithmetic progression, always the average lies at the middle, or else the mid value is nothing but the average. The average of this series is nothing but 15 only. The average of this series is 7. Average of this series is 5. Okay. And also we can find the average using the sum of first plus last, that is 5 plus 25, 30. 30 by 2 is nothing but average itself, right? Again do here. 1 plus 9 is 10. 10 by 2 is 5. Okay. 3 plus 11 is 14. 14 by 2 is 7. So, the average can also be found out by sum of the first plus last by 2. Okay. This can also be called as mean. Mean. Okay. Always the mean lies with the minimum and the maximum. Minima and maxima in between you will be having mean. So, how to find the average here? Sum of first plus last by 2. And according to the question here, if average of 15 consecutive odd numbers, 15 consecutive odd numbers means what? They are in arithmetic progression. 15 consecutive means, for example, 1, 3, 5, 7, 9, 11, these are, okay. And their average is, means the mid value is 29. See, look here. The average is given as 29 and he is asking for what? Sum of the first and the last number, right? Sum of the first and last number, can I write this as first plus last by 2 is nothing but the 29. So, what is he asking for? Sum of first and the last. Sum of the first and last is nothing but twice of the average. So, 2 into 29. Okay, sum of first and last is nothing but 2 into 29, that is 58. Always it's twice of the average if you ask for sum of first and the last in an consecutive or else in an arithmetic progression. This is the bouncer of the day. Try to solve this question and put the answer in the comment section, guys. Thank you. Keep watching the video.